So today we will start with our next chapter, which is inverse trigonometric functions. As the name suggests, here we will be talking about inverse of the 6 trigonometric functions. That is, we will be talking about inverse of sine, inverse of cosine, inverse of tan function, inverse of cot function, inverse of cosecant function, and inverse of secant function. So first, let us take our sine function. Yes, sine function is defined from r to the closed interval -1 to 1. That is, the domain of the function is the set of all reals and the codomain is the closed interval -1 to 1 and is defined as sine of x is equal to y. As we write fx is equal to y, so here the role of f, that is the role of function, is being played by our sine function. So we have defined our sine function. Now first let us see the graph of the sine function, and to plot the graph of the sine function I have taken some points. If I take x equals to 0, then y is sine x, and we know that sine 0 is 0. If I take x to be pi by 2, that is 90 degree, so y will be sine pi by 2 or sine 90 degree, which is 1. And if I take x to be minus pi by 2, then sine of minus pi by 2. We know that sine of minus theta is minus sine theta. So it is minus sine pi by 2, which will be negative 1. Sine pi is 0, sine of minus pi is again 0, and sine of 3 pi by 2 is minus 1, sine 2 pi is 0, and sine 5 pi by 2 is 1. Let's plot these ordered pairs. First is 0, 0 here, then pi by 2, 1 here, minus pi by 2, minus 1 here, pi, 0 here, minus pi, 0 here, 3 pi by 2, minus 1, then 2 pi, 0, and then 5 pi by 2, 1. Now let's join these points. So this is the graph of the sine function, and it will go on like this. So here we have obtained the graph of the sine function. Now if I ask you, is the sine function 1 to 1? Answer is no, because from the graph you can see that sine of minus pi, sine of 0, sine pi, sine 2 pi. That is, sine pi is equal to sine 2 pi, which is 0. That means distinct elements have the same image. So here the function f, which is our sine function, is not 1 to 1. And therefore it is not a bijection, and because function is not a bijection, inverse of this function will not exist, because we know that a function is invertible if and only if it is a bijection. So when the domain of the sine function is r, here the sine function is not a bijection, so therefore its inverse, that is inverse of sine, does not exist. Just now we have seen that on its actual domain r, sine function is not invertible. But if I restrict my domain to say this part, that is from minus pi by 2 to pi by 2. Now in this branch, that is from minus pi by 2 to pi by 2. This is the portion of the sine graph. So here you can see that sine function is now 1 to 1, because at distinct points the function will have distinct images like this. Similarly here also, and also the function is onto, because function is taking all the values from minus 1 to 1. So range of the function is equal to the codomain. So function is onto. So that means if I restrict my domain to this part, that is the closed interval minus pi by 2 to pi by 2, the sine function will become both 1 to 1 and onto, therefore a bijection. So I can talk of its inverse in this. Similarly, if I take this branch of sine function, that is from pi by 2 to 3 pi by 2, again you can see that the function will be 1 to 1 and onto both. So if we restrict the domain to pi by 2 to 3 pi by 2, then also we can talk of inverse of sine function. Similarly here, if I take the portion from 3 pi by 2 to 5 pi by 2, that is this part. So again the function will be both 1 to 1 and onto. So therefore we can talk of the inverse of sine function. Amongst all these branches, this branch, that is minus pi by 2 to pi by 2, if I restrict my domain to this, that is if I define the sine function as from closed interval minus pi by 2 to pi by 2 to minus 1 to 1, defined as sin x equal to y. That is, instead of taking the domain as R, I have taken my domain as this. I have restricted the domain. Now on this domain the function is both 1 to 1 and onto. So f is now a bijection. Therefore here the sine function is invertible. So inverse of sine, that is sine inverse, will exist. Now we know that if a function f is from a to b and f inverse exists, then inverse of f will be a function from b to a. And under the inverse function, every element of this set will be associated with its pre-image under the function f. So f inverse y is equal to x, and this should imply fx is equal to y. That is, the pre-image of y should be x under the function f. So here sine function is from this to this. So its inverse, that is sine inverse, will be from this to this. That is from the closed interval minus 1 to 1 to the closed interval minus pi by 2 to pi by 2. And as I said earlier, under the inverse function, every element of this set will be associated to its pre-image under the function sine. So sine inverse y will be equal to x, and because x is the pre-image of y under the function sine, so sine x is equal to y. So sine inverse y is equal to x implies that sine x is equal to y. Pre-image of y is x under the function sine. Now here, this interval is called the principal value branch of sine inverse function. I had told you that inverse function is defined from minus pi by 2 to pi by 2. And if we restrict the domain to pi by 2 to 3 pi by 2, again the sine function will be 1 to 1 and on to, so we can talk of its inverse. And in this part also 3 pi by 2 to 5 pi by 2, sine function is a bijection, so we can talk of its inverse. So if we restrict the domain of sine function to any one of these intervals, then we can talk of its inverse. Amongst all these intervals, this interval, that is the closed interval minus pi by 2 to pi by 2, is called the principal value branch. So sine function from the closed interval minus pi by 2 to pi by 2 to the closed interval minus 1 to 1 is invertible, and its inverse is from the closed interval minus 1 to 1 to the closed interval minus pi by 2 to pi by 2, defined by sine inverse y is equal to x, and this implies sine x equals to y. Here this interval is called as the principal value branch. Now look here, sine inverse of sine x is equal to x because here sine is your f and sine inverse is your f inverse. Now f inverse of fx, by definition it will be f inverse, change this to bracket fx. We know that the composition of any function with its inverse is an identity function. So f inverse of f will be an identity function, and we know that under the identity function, image of x will be equal to x. So f inverse of fx will be equal to x. So similarly, sine inverse of sine x will be equal to x. And yes, this x should come from the domain of sine function, which is this. So sine inverse of sine x is equal to x for all x which belong to the closed interval minus pi by 2 to pi by 2. Similarly, sine of sine inverse x, that is f of f inverse x, which we write as f, change this to bracket f inverse x. Now again, composition of any function with its inverse will be an identity function. So image of x should be equal to x, because under the identity function, image of every x is equal to x. So sine of sine inverse x is equal to x, and this x should come from the domain of sine inverse, which is the closed interval minus 1 to 1. So sine of sine inverse x is equal to x for all x which belong to the closed interval minus 1 to 1. And please note that inverse of sine function, that is this, is also written as arc sine.